Hi, today I'll show you three MCQ questions, same from same impact guide, old course. So 27 to 29 I'll show today. Now you see question number 27. If the graph of two lines pass through the same point, then the system of equations representing this lines is what? So you know, dear students, you see uh, if this is the suppose plane and we have divided this plane into by two axes, clear, x axis and x dash, and this is y and this is minus y. Say for if one, and they say to the same point, they say the system of equations of the lines just passes. So for one pair of linear equations, suppose we have made this line, another again for another pair of equations we are making the same line. So that means these lines will have the same slope and the same y-intercept. That means those are actually consistent and dependent. Remember, so if the lines have the same slope, they are dependent but consistent. Consistent means if they have, you get a unique solution or infinitely many solutions. Those are consistent. So here it is consistent words are there, but you will be a bit confused on the word that means dependent. So that means it has the same slope and the same y-intercepts. So that's why it should be consistent dependent. But remember one thing, but for one pair of equations, say linear equations, we just represent by a x1 plus b y1 plus c1 is equal to 0. Two pair of linear equations I'm writing, and then a suppose sorry a1 x b1 y plus c1 is equal to 0, then a2x plus b2y plus c2 is equal to 0. So I'm just writing two pair of linear equations, clear, with the same variable xy and constant term, here c1 and here c2, and here the constant terms a1 a b1 c1, here a2 b2 and c2. Now conditions just algebraically also you know, graphically also you know. Algebraically I am not showing you, I will show you in some other video. So just I'm explaining graphically. So if the system of equations intersect at one point, so one pair of, for this pair of equations I'm making the line like this, and for making a pair of these equations I'm making the straight line this. So they are intersecting at one point, clear. So this one also will have a unique solution, consistent, but it would be independent because these two lines are not having the same slope and y-intercepts, clear. While same slope, it has same slope, you know, just a steepness, we know that. I'm not discussing just from the 11, just steepness of a line, we understand on it, clear. So you know, slope of the line can be positive, negative, 0 and undefined also. So when we rise like this is positive. When we come down like this is negative slope. The slope of the line will be negative, and if it is horizontal, you know that one we just regard it as but mm, 0. Slope of the line will be 0, and if it is vertical like that, then slope of the line will be undefined. So this way it is generally be discussed. Anyway, I'm not discussing all these things, otherwise you will be confused. So just remember, when a line intersects at one point, you'll get a unique solution, and the system of equations will have consistent, clear, and independent. And if you get the for these two pair of equations getting the same line, that is coincident or overlapping with one another, then they are also consistent but dependent because having the same slope, clear. So that would be the answer. Just remember that. Now the pair of equations at x is equal to 0 and y is equal to 0 has, you see, you are getting one solution, clear, a unique solution. That means through the origin, this is the solution of this line. So the line can pass to this like this, whatever it is, but it should pass through this origin. That means it has a unique solution. That unique means one. That means when the pair of equations you are getting a unique solution, so obviously it will have one solution. So A option is not correct, B option is correct. So you write no, so I mean one solution. We are getting one solution. That is the unique solution. Clear? It is not possible infinitely many solutions. Two solutions also not correct. Clear? Now, the pair of equations are intersecting at x is equal to a and y is equal to b. So this is called abscissa and this is called ordinate. Clear? Graphically represents the lines which are what? Parallel. Parallel means you know no solution. When we draw one line like this for one equations, another for another equations, we draw like this, then when they are never intersecting each other, the distance between the two lines will be always same, then they are parallel. They have no solutions. Clear? So that means uh, parallel is not possible. Coincident, overlapping with one another, you know that. So intersecting at A and B. So you see abscissa A, ordinate B. So you're getting this. So that means the lines pair of equations, if intersects at this point x is equal to A and y is equal to B, clear, then it should be intersecting lines at this. They say the pair of equations at x is equal to A, the value of x after solving the equations algebraically we are getting this, and the value of y we are getting B. So graphically we see for suppose this is the system of equations. When you draw the lines, suppose this one and this one, and this system suppose we are getting for this distance say 2, and this distance suppose 5. The coordinates of this distance is 2, 5. We say this is your x and this is your, this distance is 5. Clear? So that means they are intersecting at 2 and 5. So the value of x is 2 and y is equal to 5. Clear? So it is a constant number. So we can say that the pair of equations at x is equal to a, y is equal to b graphically represents the lines which are coinciding, I mean intersecting at a, b. So ba is also not possible because this is here given ordinate, here given this is abscissa. So that's why it is not possible. Okay? So our option number B will be the correct one. So for today I'm just leaving up to this much. On the next day in other videos I'll show you some other MCQ. Yeah? So just slowly I'm showing 3, 4 like that. And these MCQ questions from our course. You just learn it carefully. Well, leaving it up to this much. Goodbye.